Hello everyone, welcome to the 𝗙𝗲𝗃𝗃 YouTube channel. I'm 𝗟𝗲𝗃𝗃 and in this video we are going to solve second problem from LeetCode Weekly Contest number 412. So without wasting any time, let's directly jump into the problem. So this problem is called as count almost equal pairs ones. So in this question we are given an array of integers called nums, and it is also said that we can call two integers x and y almost equal after we swap any two digits within the chosen number and they become equal. For example, let's say I have this number 5421 and as x, and y will be 5412. Now if I just swap 21 in this value of x, so 1 will become and 2 will come here. So now both are equal, right? So these numbers are almost equal. Okay, so our task is to return the number of indices I and j where I is less than j and nums of I and nums of j are almost equal. That is the question given to us. Now let's move down to an example. Okay, so as you can see here, for the given nums array, he is saying that there are two values where they are almost equal. Now, what are they? 3 and 30. Okay, so as you can see here, we have x equals 3 and y equals to 30, right? So if we, swap these two digits, we'll get 0, 3, x equals 3 and y equals to 3. So we can say both of them are 3, right? Okay, so this is one way of doing it. Okay, of checking if they both are equal. Another thing is another number pair we are talking about is x equals to 12 and y equals to 21, as you can see here. So yeah, if we swap 2 and 1 here, it will be 21 and it is also 21 here. So answer is we'll increment one more value to the answer. So total there are two pairs, so we return 2 from the function that is given to us. Now the biggest question is, how do we find out, how do we so the question, if you look at the constraints are also not so much. We have n size around 100. So generating all pairs would take around 10 power 4 time. Okay, so we can generate all pairs. Next, checking if they are almost equal is the bigger question, right? Checking if they are almost equal is the bigger question. So one thing for sure is that we have to perform this operation only once. Okay, there are few cases that we have to handle. So what we'll do is we'll try to make them we will try to figure out how to get this number. Okay, so let's say we are saying that two numbers are almost equal. I will take the same example of 5421 and 5412. So now if I just check the values at the same index, let's count the treat these as strings and check values at same index. So these two are equal, but when it comes to these two, they are not equal. So the count of not equals are 2. So what does this mean? Can we say that in one swap we can change two elements, right? So these two will become equal. So we can simply say that when we are comparing two elements and when we are going through each element and checking if they are equal, if the count we are talking about is less than or equals to 2, we can definitely say that these two numbers that we are talking about are almost equal numbers, because if I swap these two things, I'll get my number. Okay, that is one thing, but it doesn't mean that if the c value is less than equals to they are always same. Let's say I have two numbers 54 and 97. If we compare them, the c value is 2, but can they be almost equal. If we do anything, can they be equal? They cannot be equal, right? So one more check we have to do is we can simply sort them. Sorted of x should be equals to sorted of y. That is, I'm checking in terms of string, they should be sorted and they should be same. This will be 45 and this will be 79. They are not equal. So first of all, why are we doing this thing is, first of all, how the almost equal says that they should become equal. Nums of I and nums of j, sorry, yeah, nums of I and nums of j should become equal if we make one swap. So first we'll check if they are, so if they are sorted, we are getting the same number or not. And the count should also be less than or equals to 2. Then we can say they are almost equal. Are there any other cases that we should handle? So the question already gives us the hint. What would you do with numbers like this 3 and 30? How do we even compare them? So all these cases, what we can simply do is since we are treating them as strings, we'll add zeros to the front of them. We'll add zeros to the front of them. So if we are talking about zeros, okay. So when we what we can do is when we sort, these things will be anyway 0303, right? These will be 0303 anyways. But since they are zeros, when we try to compare them normally, okay, if there are two changes, the count will be to anything more than that. We cannot say uh, we cannot use them, right? Because we can apply the swap operation only one time. That is, we can swap two elements. So count should be at max 2. This will be okay. If the change required is more than that, it won't work. So what we can do for these numbers is we can just add a 0 before them so that when they are sorted, they are actually giving us the same value. And if the count is less than or equals to 2, there is only one swap required. So what we can do is, so there is no 0 here, right? So we are going to swap this and this. So the value will become 0, 3. So 3 will be equals to 3. So that is the idea here. We have three cases that we have to handle. What if the lengths of the numbers are not same? So first case, what we can do is simply make the sizes equal by adding zeros to them. Okay, after that, second step, what we'll do is we'll count how many numbers are different from each other at each position, so that we can know how many swaps we should do so that they become equal. So if it is less than or equals to 2, we can say that it is okay. But we should also make sure that sorted form, both of them should be same, right? Both of them should be same. So we handle three cases. One is for finding out the answer, validating the answer. So one is for handling what if they two are not equal. So this is the logic for our question. So let's move on to the code part and see how it goes. So let's continue with the code for this one. So what we'll do is first let's calculate the length of the array. So n equals to the length of nums. Done. We'll also declare the answer equals to 0. Every time we find a pair, we'll increment the answer. So what we'll do here, we'll just iterate over all the values for I in range n. Okay. Now the question says that I should be less than j. So we'll start one more loop from I plus 1 and we'll go until n. Okay, so this is the loop for us. So what we'll do is we'll call a function f, and this function will tell us if they are almost equal or not. And we'll pass nums of I and nums of j to this. So if nums of I and nums of j are almost equal, we'll increment the value of answer by 1. At last, we'll return the answer. That will be the number of pairs. Now let's go with the function f. Let's say we are giving two values x and y. The first thing, as we discussed, we'll treat them as strings so that our task will be easy. Okay, we'll treat them as strings. Now let's say n will be length of x and m will be length of y. Okay, so first thing, we should make sure that both the strings are equal as we discussed in logic. So what we'll do is, if n is less than m, okay, so m is the smaller one, so y is the smaller one, right? Sorry, n is less than m, so x is the smaller one. X will be equals to, we'll just add some zeros. So how many zeros are we adding? Is simply m minus n zeros plus x. So this will be a new x. And since m and n and m are now equal, we'll just update n to m. So n will be equals to the size of m. Okay. Else if what if n is greater than m, that is m is the smallest string, so y is going to be the smallest string. So we are going to add how many zeros is n minus m zeros to the string y. Okay. So yeah, we have given them the strings, and will, since both of them are equal, m now will be equals to n. So first step is done. We have balanced both the strings. Now let's declare a variable count. This is going to count how many values are not matching in x and y respectively. So what we'll do is, for I in range of n, since they both are equal, so let's just say n. If x of I is not equals to y of I, they both are not equal, we will just increment the count of c. Okay, so x of I should be equals to y of I. If they are not, we'll increment the count of c. Now we'll return. So first thing, both of them, if they are in sorted order, should represent the same value, right? So sorted of x should be equals to sorted of y. Okay, sorted of x should be equals to sorted of y. And one more thing they should all be also check is that the value of c should be less than or equals to 2. Then only after one particular swap, both the things will become equal. Right? After it matches one swap operation between two elements, both of them will be equal. So if these two are satisfied, yes, we have almost equal pair. Okay, so let's run this code. Yeah, we are accept test cases are accepted, so let's just submit it and check. Huh. So as you can see, we have successfully submitted the solution. That is it for this question. If you want to understand more such topics and want to master data structures and algorithms, join our 3-month long DSA course. You'll find the link in the description. Thank you so much for watching this video. We hope you liked it. To enjoy more such content, please like and subscribe to our channel. Please let us know in the comment section what kind of videos you would like us to create. Thank you once again. See you in the next one.